In this tutorial, I'll show you how to design an RC circuit to provide 90-degree leading. Okay, so this is our first RC value. Here R is 20 and similarly C is 20. So this will give the 45-degree phase shift, and similarly the second RC will give the 45-degree phase shift. Okay, so the output should give 90-degree leading. Okay, so I'm going Simulink and I'm taking a new model here. Okay, and I'm taking a AC voltage source, and its value is any value of the peak amplitude one, and we are basically interested in phase. Okay, so I'm taking phase 0 and frequency 60 Hz. Okay, and then we need a power GUI block. Okay, and for measuring the phase, we have to change simulation type as phasor and frequency 60 Hz. Okay, and now we need a series RLC branch. Okay, and this will be our R, and next we need a C value. Okay, so this is a C, and the R value is 20, and similarly C value is 20. Okay, so C is 20 and R is 20 also, so this value will be 20, and C reactance is 20. Okay, so the C will be 1 divided twice by F. Our frequency is 60 and its value is 20. Okay, so that's all. This will give us the C capacitance in farad. Okay, so click OK. Now, sorry, and the voltage will be connected here, and similarly this one. Now copy this C and R value here. Okay, now we need a voltage measurement block to see the output. Okay, now we are interested in the output form in magnitude angle. Okay, now click OK. Now take a display block to see the output. That's all we need, and stop time 1 second is enough, I think. 1 second. Everything is okay. Now run this model. The output should gives 90 degree. Okay, now you can see the output is giving 90 degree phase shift, whereas our input was 0 degree phase. Okay, so that's all you can how you can design your circuit to provide 90 degree leading. Okay, and you can also customize your model by changing the R and C value to get the appropriate or accurate phase shifting. Okay, so that's all for today. Thanks for watching.